everyone. A very good morning, afternoon, and evening to all. Dear authors and invited guests, welcome to Technical Session 60. My name is Anisha, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 9th World Conference on Smart Trends in Systems, Security, and Sustainability, WS4 2025, London, UK. The 9th edition of the conference is being organized in a hybrid mode. The physical event was held in London, UK on 19th August, and the virtual event was held yesterday and is being held today through Zoom, that is 20th and 21st of August 2025. I hope you all will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for question and answers. And on 10 minutes, I'll be raising a gentle reminder. There's another request to all the participants that you all please stay connected with us till the closing of the session. And if you have any query or update, then you can write it to me in the chat box. So before we start with the session, I'd just like to introduce you all to the chairs for this session. We have Dr. Karthik. He's a principal software engineer and researcher in cloud and AI at Sunrun Incorporation, USA, a visionary technology leader and entrepreneur. He specializes in artificial intelligence, cloud computing, and Salesforce architecture. With multiple peer-reviewed publications, patented innovations, and a hands-on leadership style, he bridges the gap between academic research and commercial impact. We welcome you to the session, though. And we have another session chair, Professor Preeti Parwekar. Dr. Preeti is a professor in the Department of Computer Science Engineering at GITM University, Hyderabad, India. She has been an academician from last 23 plus years. She is a member of IEEE, ACM, and CSI. Her research interests includes Internet of Things, cloud computing, machine learning, wireless sensor networks, software engineering, information retrieval systems, social media, and data mining. We welcome you to the session, ma'am.
Thank you so much, Anisha. Hello, everyone.
So now we'll just begin with the papers, and our very first presenter is Kirill Kalishkin with the paper titled Control of Vibrations and Stabilization of the Bending Mechanism of the Robotic Manipulators Movable Elements in CAD, Engineering Applications and Digital Modeling. Do we have Kirill here in the session? Any of the authors of the paper representing the session? Okay, since there's no response, we'll be moving forward to the next paper. We have Ali Abdul Fattah Al-Shahar with the paper title From Novelty to Necessity, Do Iraqis Want to Use Generative Artificial Intelligence in Their Educational Institutions? Do we have Ali present in the session? Or any of the co-authors? Okay, we'll be moving forward to the next one. We have Ridhini Gawas with the paper titled Mathematical Modeling for Predictive Maintenance, Leveraging AI and Machine Learning for System Optimization and Failure Prediction. Ma'am Ridhini, you can start with your presentation.
It's like everyone is not there, or someone will come.
Yes, Ridhini is here. We can start with her. So I'll just, yeah. So the presenter name is Arini Kolo, and the paper is titled as Validating Items of Factors Influencing Adoption and Acceptance of E-Learning Technology Model During a Pandemic, a Case Study in South Africa.
Okay. Can you see it now?
Yes, it's visible now. You can just put it in slideshow mode and we have it too.
Oh, you can't see my slide mode. Okay, let me do this. Okay. Okay. Is it okay now?
Yes.
Okay. My name is Irene Kolo from Valley University of Technology. My supervisors are Dr. Sonera and Prof. Zuba. The paper is about validating items of factors influencing adoption and acceptance of e-learning technology model during a pandemic period. This case was conducted in South Africa. What we will cover here are the definitions, methodology, the appropriateness, validity, and reliability. Then we will have the recommendations. Then we move to our conclusion. What is validity? So as defined previously by Chen and Idris in 2017, is defined as sustainability, truthfulness, relevance, and helpfulness. Sorry, I'm not sure what's happening to my screen. Can you still see my presentation?
Yes.
Still in the presentation mode, right?
No, we can see your
Yes,
paper.
it's your paper. Yeah, you've opened your paper and not the presentation.
Okay. Let me do this. Apologies about that. Okay, sorry about that. Apologies. And the reliability, it was defined as a measurement of consistency. Moving to methodology, we obtained the ethical clearance from the university, which was further approved by the Department of Education in Limpopo. And the questionnaire was adapted from previous studies that were adjusted using a 5-point Likert scale. A pilot study was performed based on the 310 responses that were correct, and the data was analyzed using SPSS version 29 and AMOS. The techniques, as supported previously by Hasim in 2020, that to check the data if it's appropriate, the KMO and Bartlett tests of sphericity can be used. And in this study, we used it. And for data validity test, the factor analysis was used. And to test the reliability, we used the Cronbach alpha. The appropriateness, that's where we check the KMO, which is considered excellent if the index is larger or equal to 0.80. And as you can see on our table, the results met the criteria. That's how we continued to the factor analysis as our data was found to be appropriate. Then we use the factor analysis for validity. So in this table is is the list of the factors numbered and fully discussed, and the figures that were obtained when we were doing the analysis. These are the items of all the 11 factors. As you can see, we have 1 up to 11, and we had all in all 38 items. Continuing with the validity, this is where we just summarizing the table, whereby we also included the factors of the items, or showing how many items belong to which factor. Then to test our reliability, as I've already mentioned, that we used Cronbach's alpha. It was supported previously that it must be greater or equal to 0.7. As you can see on the table, all the factors met the criteria of our Cronbach's alpha, as they were all greater than 0.7. Then the recommendations of this study is that this instrument should be used in another public schools. It can be the same province or different. And another analysis tools can be used to explore more results that might be different. And data collection must be collected earlier in the academic year, as the teachers' performance was not very good due to the fact that they were preparing for year-end examinations. In conclusion, it's confirmed that the instrument fulfilled the reliability and validity as expected, and all 38 items that were loaded in 11 factors found to be suitable, and the 11 factors can be used to establish a comprehensive model that can be used during any pandemic. But this instrument cannot be generalized, as it was only tested in one specific circuit and only in South Africa, in only one province. Thank you.
Hello.
Hello?
Yeah, hey, Kolo.
Yes.
Yeah, it's a nice work. I have just two questions to you. Like, have you tested the reliability? Have you faced any challenges when you are facing when you are testing the reliability?
Not really,
Okay,
as all the factors, the items under all the factors met the criteria as expected.
all right. And since you have specified that it is specific study, so in the future, I think you can make it a generic study where you can give the input and identify.
Okay, noted.
Yeah, all the best.
Thank you.
Thank you for the presentation. Yeah, we'll be moving on to the next presenter. We have Cicera Iluri with the paper title Zero-Day Malware Detection Using System Behavioral Analytics. Cicera, are you present in this session?
Good morning, everyone. This is Nihant, and I'm here with Cicera Iluri. We are so let us share our screen first. Good morning, everyone. I am Nihan Malampet, and I join with my co-author, Cicera Iluri, together under the guidance of our advisor, Dr. Faisal Kadir. And we are here honored to present our research on the title Zero-Day Malware Detection Using Behavioral Analytics.
This
This
presentation,
presentation is
sorry.
connected to 211534 VUG and Galaxy A9201.
Can I continue?
Yes, please.
Yes.
Can you mute in any one of the device?
Okay. The presentation is the result of our months of focused research on how machine learning can be applied to modern cybersecurity challenges. We actually started this project as a class presentation, but then we continued our research with the help of our advisor, Dr. Faisal. We'll walk you through the motivations, methodology, and results of our research. Um, Okay, let's begin by understanding the core motivation of our project, of our presentation. The malware is no longer what it used to be. Uh, Previously, the traditional systems were more reliable to detect malware, but now, uh, as a technology developed, malware also grew, and attackers are getting smarter and faster and stealthier. Uh, uh, as the malware is always changing, the traditional defenses or traditional methods to detect malware is no longer reliable. What happens when a piece of malware is completely new, when it is not system based or it is not predefined? Uh, that's where the term zero day comes in. It refers to vulnerabilities that is completely new, that the system cannot detect because it is new. These zero day attacks are really dangerous, as there is no sign of it, and there is no, it's completely new. In this study, instead of focusing on what malware used to look like, um, we are analyzing the malware. We are trying to uh, eradicate the malware by analyzing the system behaviors like CPU spikes, memory usage, and abnormal memory usage, and suspicious network activity. Usually, these behaviors are hard for attackers to identify and provide a path for early detection. Uh, the challenge we tackled is simple to state, but deeply complex to solve. Like, how do you detect something you've never seen before? Zero day malware doesn't carry inidentifiable traits. They're identifiable, but it's just that we have to uh, run it run it very clearly. It often hides within the normal activities like familiar paths, the regular network trafficking, and yeah, traditional rule based, like traditional systems that are present before, fall short because they depend on predefined or prior knowledge. Our solution is dynamic and adaptive because it lies in understanding of the system and then flagging the behavior of the malware. With that challenge in mind, our main objective was to develop a main machine learning model framework capable of detecting the zero day malware using system behavior analytics. Instead of relying on file hashes or signatures, we monitor the metrics like CPU load, memory access, and effectively built a dynamic profile. So, what we did was our approach started with creating a controlled data set. We did that, we collected the data, then we handled the missing values, handled the duplicate values, then uh, then we encoded the categories like converting the text to numbers, numerical values. Then we engineered the behavioral features like uh, memory jumps, unusual outbound connections, etc. Then we tested the model with three machine learning models like Random Forest, XGBoost, and LightGBM. These models were trained and tuned tuned and trained on 80% of the data and tested on remaining 20% of the data. We evaluated these with the standard classification metrics. Um, the main key for the whole detection was feature engineering. It was since we were not relying on file signatures, we had to extract signals from that reflect the system's real-time behavior, actual behavior. For example, CPU spikes.
Coming to the experimental setup, to validate our approach, we split the data into the traditional split, that is training with the 80% of the data and testing with the 20%, like to simulate the entire deployment scenario where we can where we can see whether it is performing accurately or not, and then we evaluated each model based on this accuracy, precision, recall, F1 score, and ROC AUC curves. And also we went a step further by calculating the false positive rates, which, like, when a normal activity is wrongly flagged, then we consider it as a false positive rate, and then when a malware is mistakenly ignored, then we considered it as a false negative rate. And then coming to so our aim was to find a balance between the sensitivity and usability. And then coming to the results were highly promising. Like, all the three models that we tried, the random forest attribute and the IBGM, were uh, performing consistently, and the accuracy was almost up to 99% for all the three things. Like, more importantly, the behavioral features were engineered to be strong predictors, like all these memory usage, which the unusual port communication, which were consistently ranked among the top precisions in the feature importance analysis. And what the takeaway is that, like, the behavioral indicators can effectively substitute static signatures, and they not only detect attacks but also generalize new unseen ones. Like, coming to the behavioral insights, the insights what we uncovered were both intuitive and revealing. Like, certain behaviors consistently stood out in the malware activity, like high CPU usage outside the scheduled task windows, like, and also unusual write frequency to system 32 or the other stuff. Like, these are the patterns that form a behavioral profile that hard for the attackers to fake, like, especially when evaluated across multiple metrics simultaneously. This highlights the strength of behavioral modeling, unlike signature based systems, which can be tricked with a simple abstraction. Our model learns the underlying intent and impact of the behavior. Like, as a threat continues to evolve, this approach gives us the defenders for a forward approach. And the challenges and the limitations that we have in our research were, like, no particular research is without its limitation. Like, our current data set was stimulated in a controlled environment, while we mimicked it with the real malware behaviors using the known patterns that and system manipulations. It doesn't fully capture the variability and noise of the real world environments. And additionally, sophisticated malware often includes evasion techniques such as delaying execution or mimicking the legitimate process behavior. These may reduce detection effectiveness in a live setting. Uh, so, coming to our future work, that looking ahead, we've mapped a clear path for extending this research into a real world application, like edge develop. One of them is edge development, optimizing the model for IoT and embedded systems where local or real time detections is valid and connectivity may be limited. And the other one would be cloud integration, like scaling the solution into enterprise cloud environments with real-time alerting and visualization dashboards. Next, to conclude, our work demonstrates that machine learning, when combined with the behavioral analytics, offers a powerful defense mechanism against zero-day malware. By focusing on how systems behave rather than what file looks like, we show that the possible to catch threats that are traditional miss. Like, with 99% plus accuracy, low false positive rates, and resilience to unknown threats, our framework offers a promising foundation for a proactive cybersecurity. Next, we've grounded our current work in current literature across malware detection using the machine learning and behavioral analytics. Our references include benchmarks, data sets, and methodologies that are inspired in the study. And we are happy to share them and provide them during our QA session. Thank you so much.
Yeah, hello. I think Nihant and sister.
Hi.
Yeah, when you have used this random forest and the other algorithm, I think it's a classification, right? So was it a class?
Oh, sorry, I didn't get you. Was it
Is it
a
a multi-class classification? In your classification, what was the ultimate classes what you have got as a categorized?
like our problem was framed in such as a classification task where we use system behavior logs and label them as a non-malicious and malicious kind of thing. Like while we using this random forest, XGBoost, and light BGM models, these learn from those labels to classify new activity, either it is a normal activity or a potential zero-day attack. Like uh, that's how we categorized it.
Now, when you go for 0 day,
Yeah, like
exactly you identify that this is the 0 day and from the day when the vulnerability has started, according to your algorithm.
uh so what we did is like we have done with a limited data set, and our algorithm comparison that confines to just that limited data set, so that whenever a thing that is not in our training data set or the testing data set comes out to be true, then our algorithm throws us an thing that this is a new kind of data set and might be a zero-day attack.
That this is a very generic answer what you have given. Okay, what is the limited data set? What was the size of the data set which you have used?
uh, so size of the data set was around, we had it around like 20,000 plus of recordings, which were split into 18 to 20%.
How many features have you extracted?
We had around so we had around 20 to 25 features, but we then categorized some of the features and labeled them as important, like uh, the different kinds of attacks that we have in our day-to-day life, and label them as the high priority kind of stuff, and then we train them.
Okay, just one advice. If you are using a 0 day, you can modify this algorithm for GAN, generalized adversarial networks. You can use for it. And if you are doing continuation of your research in this field, then that will be helpful for you.
Yeah, sure. Noted. Thank you so like
Good luck.
yeah, you noted. Thank you so much.
Thank you so much for the presentation. Now we'll be moving on to the next presentation. We have Mridini Kawas with the paper titled Mathematical Modeling for Predictive Maintenance, Leveraging AI and Machine Learning for System Optimization and Failure Prediction. Mridini, are you here in the session?
Yes, hello, ma'am.
You can go ahead with your presentation.
So my screen is visible. Hello.
Yes, the screen is visible.
Yeah, okay, thank you. Yeah, myself, Dr. Mridini Gavas, and I'll be presenting a joint research work by myself and Dr. Mahadev Gavas. Mathematical modeling for predictive maintenance, leveraging AI and machine learning for system optimization and failure prediction. So the outline of my presentation will be abstract, introduction, then I'll be talking about the literature review, then the proposed methodology, results and discussion, and finally the data acquisition and pre-processing. So the rapid growth of data-driven technologies has created a strong demand for models that are accurate, easy to understand, and scalable for both science and industry. So our focus is on combining the delayed differential equations with the machine learning to improve predictions in complex dynamic systems. Earlier works has relied too much on purely statistical or black box models, which are often hard to interpret. So they also fail to remain robust when applied to real world diverse data and struggle to capture time delays and dependencies. So our work aims to overcome these gaps and provide better solutions for the real applications. The problem statement, the core problem we addressed is how to build a hybrid framework that combines mathematical modeling with machine learning to capture the time-based dynamics and predict the system behavior more effectively. The goal is to achieve the high accuracy in predictions while keeping the models explainable and adaptable to different types of data and application areas. At the same time, we have worked within the practical limits such as the low computational resources and the need for the real life use. The success of this work will be measured by how accurate, robust, scalable, and interpretable the framework is in the real world situations. Some main contributions are in the four areas. So talking about theoretically, we integrate the delay differential equations with machine learning models to better capture how systems change over time. On the algorithmic side, we design a dual pathway deep learning architecture that uses attention mechanisms to handle different types of input data. Practically speaking, we show that our model or our method works well in real biomedical and engineering applications, giving more reliable predictions. The novelty of our work is that it is the first to systematically combine the analytical mathematical models with modern deep learning methods in one unified framework, you can say. Talking about the related work, the related work in this area builds on two main foundations. The first is the classical approaches such as the compartmental and the differential equation models, which have been widely used in epidemiology and the system dynamics. The second is the standard supervised machine learning methods like SVMs and artificial neural networks. So these methods are strong because they give structured ways to understand system behavior. However, they also have some limitations like the poor scalability when dealing with the large and diverse data sets and difficulty in modeling long delays and complex interactions. Yeah, the recent trends in related work also includes deep learning models like CNNs, RNNs, and transformers, which are used for time series analysis and biomedical imaging. Another direction is hybrid AI systems that combine the physics-based constraints with the machine learning to improve the reliability. The state of the art now also uses the attention mechanisms for better interpretability and graph-based neural networks for handling structured data. Our work builds on these ideas, but it goes little further by tightly coupling the delay-aware mathematical models with the neural networks, so which enables more robust and accurate temporal predictions. The methodology. So our methodology follows a clear pipeline that is data collection, then processing, then mathematical modeling, deep learning, and finally the evaluation. So we designed a dual pathway ResNet with attention to handle the heterogeneous inputs effectively with delay differential terms are included during the future engineering to better capture the temporal effects. The approach assumes that the system dynamics naturally include time delays and the spatial differences. To ensure the robustness, we validate the models across multiple data sets and apply the regularization techniques to support the good generalization. Coming to the core component, the core component of our work is to capture the temporal delays directly using the delay differential equations. The algorithm works in three main steps. First, we define the system dynamics with the delay terms. Second, we transform the output into the structured features. And third, we feed these features into a neural model for further refinement. Now, to handle the complexity and scalability, we use efficient numerical solvers and reduce the computational load through parallelization, making the approach practical for the larger systems. Again, the core component here is a neural network pathway that captures the non-linear patterns and high dimensional features. So it integrates the output from component A with other data types such as imaging, then genomic and spatial inputs. So since it needs large scale training data, we handle the risk of overfitting by using the dropout and attention based regularization. So in cases of extreme noise, the model may lose the accuracy, but this is reduced through careful pre-processing and hybrid error correction methods. So here is the key equation which we are using, where this capital R of t is the remaining health of the component at time t. Then alpha here is greater than 0, and it is the degradation rate coefficient. N takes the value greater than or equal to 1, and it is a degradation nonlinearity exponent. Yeah, and we just have solved this particular equation, and it has a solution just by integrating R of t is equal to R naught e raised to minus alpha t, where this R naught here is the reproduction number. So the optimization and the learning objectives, here also we have a similar equation with this, same terms. We have this R naught as the reproduction number. Then the data and experimental setup. So our data and experimental setup include details of the database sources, how the data is split into training, validation, and testing sets, and the key statistics of each. So the implementation is carried out using the standard deep learning frameworks, and the experiments are run on hardware with GPU support to handle the computational needs effectively. Here the ANN model tracks the actual RUL trajectory more closely than the SVR. The deviations in the ANN predictions are mostly contained within plus or minus 5 cycle band for over 85% of the engine life. Then in this particular diagram, you can see that the ANN displays a tighter error distribution centered near 0. The SVR shows a broader with more frequent larger errors, particularly during the late life predictions. The quantitative research. So our quantitative research show that the proposed hybrid model achieved an accuracy of 94.2%, which is higher than the baselines, with ANN at 85.5% and SVM at 86.7%. The F1 score stayed strong at 0.93, showing a good balance between the precision and recall, while the AUC value of 0.96 confirmed excellent discriminative ability. So our ablation and sensitivity analysis showed that removing the delay component reduces the accuracy by 6 to 8%, while removing the attention module lowered the interpretability and dropped the F1 score. The temporal misalignment in the data led to about 4% errors, and some outliers were found in the regions of the feature space that had very few samples. Finally, the overall discussion and the limitations. So our discussion highlights that hybrid modeling improves the prediction reliability in both biomedical and engineering systems. The delay-aware framework can also be applied to areas like epidemic modeling, IoT monitoring, and predictive maintenance. However, there are some limitations. Training the model requires large computational resources. Its performance depends heavily on high quality temporal data, and noisy time series can reduce the robustness. In addition, its ability to generalize across very different domains such as finance, biology, still needs to be tested. Yeah. Conclusion. In conclusion, we introduce a new hybrid framework that combines the delayed differential equations with the deep learning, achieving higher accuracy and robustness that both traditional models and pure machine learning methods. The work shows the broad applicability across the different domains, proving that the delay over modeling captures important temporal dynamics often missed by the standard machine learning. So attention mechanisms further improve both the interpretability and the performance, helping the bridge the gap between the theory-driven and the data-driven approaches. That's all. Thank you so much.
Hello, Ridhini.
Yes, ma'am.
Yeah, can you hear me?
Yes, yes.
So you have used a optimization technique, am I right?
Yes.
So can you go back to what fitness function have you used? Can you take me there?
Yeah, this is the key equation, ma'am. And here we have the optimization.
All right. So in this optimization, can you just explain me the parameters? You're trying to
Here,
minimize or maximize? Minimize, right?
minimize, because R of t we are taking as the remaining health of the component at any time t.
All right. Then why have you said that you have used a hybrid thing? Is it like, have you used any hardware?
We have that part that is which is AI and machine learning, that is done by the co-author, ma'am, Dr. Madhav. He's from computer science and I'm from mathematics background. So whatever is with this delay differential equations, I'm working in differential equations. So that part has been done by me.
All right. And may I know the application of your work?
Yeah, this can we have many models in epidemiology as well as the biology. Also, we have this predator prey model. So many models are there. So that if we combine these models with the delay terms and the AI machine learning, then it will give the more appropriate solutions or the results. Because like earlier, we had models which contain just the differential equations. So now this delay differential equation, that delay meaning we are considering the time delay, that is the value of the function at t minus tau. So what is the value of the function at the behind time, you can say. So with that, the results or the solutions what we get are more appropriate.
All right. Understood. Wish you all the best for your research. That's
Yeah,
the
thank you, ma'am. Thank you so much. Yeah.
Thank you for the presentation. We have three presenters who haven't presented yet. I'll just quickly re-announce the names if they are present in the session now. The author names are Kirill Telishkin, Ali Abdul Fateh Al-Shahar, and Mr. Ulma Siddiqui. Do you have any of them in the session? Okay, so then that brings us to the session. So I sincerely thank all our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for you all. We, on behalf of the whole team, we thank you for your support during this ninth version and all the previous 8 versions of the conference. We will be happy to have you with the 10th version in 2026. All the presenters will be getting their digital certificates within email within 2 working days, and the publication will be live within 7 to 8 months. So kindly cooperate with the team of WS4 2025. I would also like to thank our session chair, Professor Preeti Pawekar. Thank you for joining us in this session, ma'am. Would you like to give any closing remarks to all the participants?
Yeah, thank you, Anisha. Uh, I mean, we had only few presenters, but that's okay. Maybe all of them could not present the paper, but it was good to listen to all the research areas. And I wish all the best to all the researchers. Thank you. And thank you for having me.
Thank you so much, ma'am. So as now, in the end, I'll just request you all to please turn on your cameras for a quick snapshot. Okay, thank you so much. See you in the next one. Take care.
Thank you.